Descriptive statistics. Under this, we have central tendency and variance. Today, we're going to look at central tendency. All right, that's under descriptive statistics. So, central tendency is simply the average. You know, average normally is first we think that average is the mean, but average can also be the mode, which is the most common item, or can be the median, the middle item after you've ordered them in order. So central tendency is the extent which all data values group around a typical or central value. Let's first look at that. And the common measure is the mean. And we know the mean is the same as summation of all items divided by number of items. And sometimes it can also be written as x bar is equals to the summation. This symbol means summation from I equals to 1, the first item 1, to the nth item, which is the last item, divided by n, which is number of items. These two are the same. This is just confusion.
This guy in.
It means the nth item, the last item, the item 1 to the last item, divided by number of items. Yeah. So that is the mean. And if we look at an example.
After you are going to share it.
Yeah, I'll share everything.
No, you are going to share to everyone.
Yeah.
No, not my.
So let's look at an example. Okay, we have here two examples. Example 1, we are given items 11, 12. This is what I'm looking at. We're given 11, 12, 13, then 14, and 15. And they're asking us to find the mean. Then in example 2, which is this one, we are given 11, 12, 13, 14, 15. No, there's no 15.
It is 20.
And 20.
Outlier.
So when we are working on, exactly, I'm trying to show you the concept of an outlier, which I'll get to that later. So when you're working on number 1, you have and do it.
I'm going to do number 1. Also,
the values are there.
Yeah, I'm going to add these ones also.
Yeah.
Hey, remember that it is summation. That's the answer.
That's the formula.
Then we go 11 plus 12 plus 13 plus 14 plus 15. Also.
Yes.
I will tell you 1, 2, 3, 4, 5. Also.
Yeah. If you add this, I think you get 1, 3, 4, 5, 6, 10, 15, 5 carry 1. 1, 2, 3, 4, 5.
Started to the answer.
65.
65.
Yeah.
65 divided by 5. Yeah.
And that is 13.
13,
yeah? Is the mean. You can write there x bar. Mean sample. No. Yeah, this side.
X bar
equals to 13. X bar is the symbol of mean. Yeah.
X bar.
Now you do the same for example 2.
This one without an outlier.
Yes.
Example 2 is using summation x is equal to it is 11 plus 12 plus 13 plus 14 plus 20. So
yeah, 1 plus 2, that's 3, that's 6. This is 10. Carry 1.
Yeah.
1, 2, 3, 4, 5, 6, 70.
1, 2, 3, 4, 5. Let's go to 70. Okay.
That is 14. You can put x bar. Alright. So, yeah, we have got the exact values.
Yeah.
So, in the first example, the numbers were close. We had 11, 12, 13, 14, 15, and we got our mean as
As
13.
yeah.
But in the second example, there was an outlier. An outlier is a value that is far from the rest. For example, common example we saw in
It's also
graduation.
extensive value.
Yeah?
Extensive value.
Extreme value.
Extreme, right?
Extreme value is also known as outlier. I'll give an example of graduation. Those who were following the statuses of those find
Yeah.
that some people spent 3 years to graduate, others 4, others 5. But there was a guy who spent 10 years
Yeah.
doing architecture from Mitchell Hall. So he's an outlier. That's why he was very celebrated and that. So an outlier is an extreme value.
Extreme
One that,
value.
if, for example, if we look at our class, let's say we have, these are the ages of people in our class. We have people 11, 12, 13, 14. But there's one guy who's 20.
Yeah.
He becomes an outlier.
Yeah, an outlier.
Yeah. So I think mean is clear. Now, median is the next concept we shall look at. Okay. One thing we have seen, we have been able to observe is that mean is affected by
an
outliers or extreme values.
Yes.
So that means in a scenario where you have extreme values, when you choose to pick a measure of central tendency, you may choose to leave out mean. So if you're not using mean, then now you go and consider what? The median. And we are going to see what the limitation of median is as well. So here, first of all, you have to know that median, the data has to be ordered. It's the middle
order.
value in an ordered array.
Either ascending or descending.
Yeah,
Also.
but commonly we use ascending order.
Ascending order.
Yeah.
Also.
Now using the same figures, go ahead and calculate the median.
Okay, median. 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 I have 11, 12, 13, 14, and 15. Remember that I want that one in the middle. This one. It is 13 also.
Yep. Now go ahead and do it with example 2.
Example 2. This is a 1. It is 11. It is 11 plus 12 plus 13 plus 14 plus 20.
Plus. To rub,
No, it
to rub, you press here. Then,
I made a mistake.
yeah.
Yeah, it is 11. Yeah. And 20, not so.
Yeah.
Then I have to look. I want a middle. It's still 13.
Yeah. So you realize.
Median is not affected by an outlier.
Oh, extreme value. Perfect. So median is not affected by an outlier extreme value.
But mean is affected also.
Yes. Okay. Now this is a simple example whereby we know the items are few. But now in a scenario whereby you give you maybe 100 items, how are you going to calculate the median? You know the process? So to calculate the median, we shall first find the median position. Median position, which will be the number of items plus 1 divided by 2. So you realize two scenarios. There is an odd scenario and an even scenario. And we handle those scenarios differently. So let's take an example of an odd scenario. And let's say we have a very big data set of maybe 65 items, and they want us to find the median. So it will be median. So the median position will be position will be 65 plus 1 divided by 2, which is 66 divided by 2, which is the 33rd position. 33rd position.
Yeah,
So now you go count your items, and the 33rd becomes the median. So this one is obvious. So the 33rd item equals median. That is obvious. Now we have a scenario whereby we are given odd number. Let's say we are given 60. Let's say we are given maybe 78 items. Our median position shall be 68 plus 1 divided by 2, which is, 79.
70.
78 plus 1 divided by 2, which is 79 divided by 2, which is 3 carry 1, that is 18, that is 9, 39.5.
39.
So now here,
5, 8.
you see 39.5 lies between 39 and 40. So here we shall consider the 39 and 40th positions. So you go pick your items on the 39th and 40th position. Let's say for our cases the figures are maybe 105 and 107. So to go ahead and find the median, we shall find the average of these two. We shall find the
Shall add then and we divide. No?
So 105 plus 107 divided by 2 equals to 106. The answer is 106. Yeah. If you do step by step, 212 divided by 2, which is, wait,
71.
What is it?
71.
105, 107, 2 carry 1, 2 and 2.
It is 71, I think, not so.
Divided by 2, what do we get? 21 divided by 2?
Hey, 21 divided by 2, that is the
10, remainder 1.
Remember, that is 6.
12 divided by 2? 6. So, when you're working with median, if they are odd, that one is easy because the middle value the middle position will be. But if you're working with even number of items, you'll end up with 2 median positions because of the 0.5. There is no middle position in between 2 things, so 2 items. So you consider the 2 adjacent items and you find their average. For this case, 106. Yeah. So the location of the median where values are in numerical order, smallest to largest, we use this formula. And if the number is odd, the median is the middle number. If the number of values is even, the median is the average of the 2 middle numbers. Yeah. So this formula, once again, is not the value of the median. It's only the position of the median in the ranked data. Yeah. Now, we have seen median. Now let's go and look at the third measure of central tendency, which is the mode. So mode is simply the most common item or the value that occurs most often. Mode is not also affected by extreme values. It is used for either numerical or no, it's okay. Yeah. So the value that occurs most often, it's not affected by extreme values, and it works best for either numerical or categorical data. And also with mode is interesting because we can have cases where there are no modes, and we can also have there may be several modes. They've given us here 2 examples. Example 1 has items 1, 2, 5, 7, 9, 10, 12, 13 and 14. And then example 2 has items 0, 1, 2, 3, 5, 6. So you get the boards for those scenarios.
You just 5, 2 times this one 3 times. I think the mode here is 9 also.
Yeah,
here is 9 also.
Yeah.
Let me see here. Yeah, I'm not seeing any mode.
Hey, so there is no mode.
No mode.
All right. So you realize in the first scenario it was easy to find a mode, and in the second case there is no mode. Now in circumstances, let's use the first example. Let's say you're given 100 items and they're all not in order. For you to calculate it, what you would do, you would do a frequency table. You'd have your values 1, 3, 5, 7, 9, all of them. Then you put here. This is the x, which is the values. Then you put here the tally. So tally. Now you go on crossing 1. You put 1 like that.
Tally.
Let's say you end up here with the following tallies. You cross 1, you tally it. Let's say you end up with that data, then you go ahead and put the n. So you have here 1, 3, 3, 5, and 10. So you come and say the highest value is 10 in this scenario. So 10. So that means our mod, the x value which is connected to 10, which is 9. That's how you do if you have many items which are disorganized. You need to tally. But for this case, it's obvious. You can just see and tell.
And you combine that.
Now, let's say also the same information. Instead of having it like that, I just change only one thing and remove one of these 9s. So what is the mod?
What's the mod? Yeah, this one tells 2, this one tells 2, this one tells 2.
So
what's the mod?
The mod is 5 and 9 and 12. So you can have many mods. So here the mod is 5, 9 and 12. Yeah, that's it. And here we are looking at examples. We have already covered examples. So when do you choose what? When do you choose which measure of central tendency? When do you choose mod? When do you choose median? When do you choose mean?
As in when they ask me, how you find this?
No. You're looking at now statistics. You're the person who is collecting, not doing an exam. You're there in the field, you've collected data. How are you going to represent it? So now they're going to explain to us. So mean is generally used unless extreme values or outliers exist. So
if
you find
get an outlier, it means that you have to use a mean.
The median. If there are no outliers, they use the mean. And it's the common one. You find
if no outliers, you use the mean.
So mean is generally used, especially where there are no outliers. We saw that mean was affected by outliers. So you find that it's the one which is generally used. If you find any information that is the average, and they're referring to mean, the mean age, the mean number, the mean income, you get it. So mean is the one which is generally used. But if there are no but it works when there are no outliers. If there are outliers, then you don't use the mean. You go for the median. So the median is often used since the median is not sensitive to extreme values. For example, median income may be reported for a region. It is less sensitive to outliers. So this works if there are outliers. Then the mod. Okay, in some situations it may make sense to report both the mean and the median. Sometimes you may need to report both. Now the mod, I don't know if it's given somewhere here. So the mod for it, it's used especially for categorical data. Now, categorical data, let's say now crops grown. Now we say crops grown, we have maize, we have beans, and we have, let's say, potatoes. You've gone to a village as an agriculture officer and you've gone to collect data, and now you've ended up collecting the number of people growing maize. Maybe let's say there are 1,000. Potatoes 1,000, maize 2,000, and then beans maybe 500. And now you say you want to represent this data, you want to communicate to your bosses. They have asked you, what did you find out? So here, in this case, you will not go and say that the average number of or the median number or crop or what. So in this case, you go and say the most common crop grown was maize. Yeah. Then now we go and we look at so that is it. Measure of central tendency. This is a summary. Arithmetic mean is simply total number of items divided by number of items. The median is simply the middle value in an ordered array, and the mod is simply the most frequently observed value. And when do we use mod? When do we use mod?
We use mod when we are looking As in like a man, you are talking.
When do we use the median? The mean.
The mean we are looking, as in like when you don't have an outlier, not so.
Yes.
Yeah, of course we have to use a mean.
So when do we use the median?
Median when you have an outlier, because an outlier, it's an extent value, like it is extreme.
Extreme, eh?
Yeah, I mean it's extreme.
Yeah. So median is not affected by extreme values. Now when do we use the mode?
Mode, of course, no outlier.
Mode.
The most appearance number. Not frequent, the more frequent.
It works best for categorical information.
Most frequent, yeah, categorical when you're organizing them, like bring your grouping them,
yeah,
organizing.
And the next measure of central tendency is the variation. Variation it gives us information on how spread or dispersed the data is. So we can have, let's say we go and collect data on ages of people in our class, and we have 19, let's start with 16, 18, 20, 22, 24. You'll realize that maybe 20, they are, let's say this is 10, 20, 30, 40. There are 40 people who are 20 years old. Then maybe 18 years old, you find that there are some 30 people. Then 16 years old, you find that there is none, 0. 24 years old, there is none. 22 years old, we find also there is what? 30. So we end up with something of this curve. That is one scenario. The other scenario, now, we are looking at the university as a whole. And we are now looking at maybe a different group, and you find that in this group, there are people even who are 14 years old. So they start from 14, maybe, and they 20, and then up to maybe 28. So these are two sets of data. Now you see this one, the way it is spread, and this one is different. So to know how spread that the value is, the data is, we measure the variation of the data. How, like now, what is the variation of the age? And you say that, okay, we know that the mean age in our class is 20 years, but it varies by how much. So you say give or take 2 years old. So that means the youngest person, or give or take 4 years old. That means the youngest person is probably 16, and the oldest person is probably 24. That is the variation. Yeah. Now we go ahead, we look at the range. There are measures of variation. The simplest is the range, what is the range?
Range. Yeah, when you're calculating the highest minus the lowest.
Highest minus lowest. The oldest in our class, 24. The youngest, 16. So the range, if you do the math, no, 8. Yeah?
No, it's true. No. That is 8, man. It's not
8, okay. So that means the age of students in our class ranges by 8 years old. The difference between the youngest and the oldest is 8. That's the meaning of range. Now variance. Here we are getting a little technical, but nothing scary. Okay, before we move on, just more on range. We see that range is the simplest measure of variation, difference between largest and smallest. And they are showing us here an example. 13 minus 1, you get 12 is the range. But the range can also be misleading sometimes. Why it may be misleading? Number one, it ignores the way the data is distributed. Like you can see clearly here, that in the case whereby we have 7 to 12 and all of them 1, and here 7, 10, 11, then 3 of them are 12, you find that they are given the same range. So this does not give enough information. Also, the range is very sensitive to outliers. Here we see an example from values 1 to 5. And if you see the range is what? 4.
It's 4.
Here we are seeing example values from 1 to 120. And you see the range is 119. So it's very sensitive to outliers. More and more sensitive than the mean. So that's why we go on to the next what measure. That's why we say, okay, since the range is not enough, let's now do variance. So variance, what I was illustrating earlier on was the word variance. If the data very close, is the data very dispersed. So if it's very close, that means it has a low variance. If it is very dispersed, that means it has a high variance. High variance, low variance. It's just how close is it to the mean? How close is it to mean? So it's the measure. So measure the distance to the mean. And how we calculate it, it's defined as average of square deviations of values from the mean. Square deviations from the mean. So if you have your items, like in our case here, we see the deviations from the mean. So 18, let's say they are what? 30 people, and the mean is 20. So 20 minus 8. So we say 18 minus 20, which gives us minus 2. The next value is those who are 20 years old. 20 minus 20, which gives us 0. Next value is those who are 22 years old. 22 minus 20 gives us 2. But now if you add this up, it will end up going to 0. So what you do, you square all of them. So this is the deviation, which is x minus the mean, x bar. You always have to know the mean to calculate the median. Then now, so if you square that, you find this is 4, this is 0, and this is 4. When you sum it up, you get 8. And when you divide that by the number of items, which is n, in this case it's 3, you end up with some figure. However, if you remember, when we are looking at data, there is what we call sampling of data, whereby instead of going to find out the data for the whole population, you pick a few people who represent. You go to our class, you pick a group of 10 people, then you ask them their ages and you work with that. So whenever you're sampling, you need to do a sampling correction to account for some errors. So instead of dividing by n, we shall divide by n minus 1. I don't know if you understand. So in this case, we shall divide by 8 minus 1, which gives us 8 divided by 2, which is 4. So in this case, the variance is 4. We shall look at a better example later on. That is just to show us. So it's the most commonly used measure of variation. It shows the variation about the mean. Is the square root of the variance. Okay, yeah, I've moved on to standard deviation, sorry. Standard deviation, the sample standard deviation is the most commonly used measure of variation. It shows the variation about the mean. It is simply the square root of the variance. SD, standard deviation, sometimes written as sigma. Okay, for a population, sigma. For a sample, S. Probably, okay, let me not get into that. So standard deviation is simply square root of variance. We saw how to calculate variance. Do you remember?
We got 4.
X minus x
X bar
minus x bar squared. Summation divided by n. So that means our SD shall be square root of summation x minus x bar squared divided by n. But since we are dealing with sample, n minus 1. So in our case, our variance was what?
It was 4.
So our SD is
2.
That is it.
Oh Jesus Christ!
So let's say we're dealing with years. So here our standard deviation, the units will be years. But for variance, because of this squaring here, which we did here, squaring here, our unit will be years squared. So you see why we like to use standard deviation, because it's the same unit as the data. Yeah, it's the most commonly used. So measures of so here they are telling us this one with smaller standard deviation. So since you know standard deviation and variation are related, so they look the same. This one with a smaller standard deviation, they have many close to the mean. This one with a larger standard deviation, they have many. So ignore the height. We can let me sketch a different diagram. Are you seeing? So you tell me which one has a higher standard deviation and which one has a lower.
Which one has a higher standard deviation? This one. Not so.
Yes.
It is this one.
Yeah, you label it. Put an arrow and say larger. Then the other one?
This one.
Smaller. Perfect. Now locating. Let's not get into that yet. Let's do an example. I don't know if there's an example down here. That is clear. Yeah. We are given those incomes. Here. And they're asking us to calculate the. Start by the calculating the range. So what is the range?
Okay, range is equal to highest minus lowest, not so?
Yes.
Then we have to look for the highest. The highest is 2 million, not so?
Yes.
We have 2 million, not so? Minus the lowest. The lowest is 100,000, not so?
Yes.
Then yeah, it is simple, I think.
1,900,000.
1 million. I made a mistake.
Yeah, you are. Yeah, 1,900,000. Alright, now you go and calculate the variance. You're going to need to use a table.
Okay.
So how are you going to find the variance?
Yeah, I'm going to first find the mean. The mean. The mean, as we know. I'm going to first find the mean. I'm going to first add.
You don't need to write that. You add in your calc, then you just put the answer.
Oh my goodness, I can't believe this. This is 2 million plus
500,000 plus 300,000 plus 100,000.
I think let me just say 2.
Okay.
200,000.
200,000. That gives you 3 million. So the summation is 3 million.
Divide into.
So you write 3 million. Divide by. There are 5. Yeah, that's 600,000. All right.
I think that is the mean.
That's the mean, 600,000. Now you go ahead and.
So I'm going to make a table. Not so. Okay. This is X, not so?
Yes.
2 million, not so?
Yes.
2M, not so?
Okay.
Okay. Yeah,
All
symbology. I know.
You rub that 2M and put 2 million.
Okay.
All right.
Okay. This is X, not so?
Yeah.
But I had to squeeze anyway. I'm going to get this one. Yeah, are you seeing this one?
Yeah.
Minus the mean, not so?
Yeah. Our mean is 600. You write the answer straight away.
Yeah.
2 million minus 600 is
It's
1 million.
1.4.
Yeah, 400.
Also?
Yeah. Negative 100.
Negative 100.
Yeah.
Negative 100.
Negative 300.
Negative 300.
Negative 500.
Man,
It's okay, don't
man,
mind.
I do now. No. Negative 500.
Yeah, don't mind the way they are ordered. The negative 500. Alright. So you see those negatives. If you were to add up, you may even end up with 0 as a sum. So what do you do?
As a sum. Because I'm going to square.
So you
Right
square.
now I'm going to square. I get this one.
And you pull out the calc.
And my calculator. Okay, 1.4
Times 1.4.
times 1.4.
M. Put there M.
Even
1,960,000 M.
yeah.
You press. 1,960,000 M. 60,000, because that is 1 trillion. Hey, you haven't been recording.
Okay, I think let me first put these 3 zeros, then M.
Yeah. The next
Then
one,
It's
500,000.
negative. Oh my goodness.
Times.
Time was still the same, but it is in negative.
It becomes positive. Negative times the negative is positive.
It's positive.
So 10,000 M.
Then
Next.
this one. It is a 3.
100,000.
Wow, baby.
Remove 1 0, yeah. So 90,000 M.
Yeah. But I think it is too big, man.
Yeah, space.
It is this times this.
50,000 M.
I think
The same. 250,000 M. Alright. So now you sum them up. So just write here summation of x minus x bar squared, and you will do the calculation. So you start adding 1,960,000.
Let me just take this one's times 2, so.
No, we don't want to what? We don't want to put the millions.
Okay.
1,960,000.
1,960,000.
960.
My calculator.
1,000 plus 10,000
Plus 10.
10,000
Plus what? Plus 90.
1,000 plus, this is 10,000, not 100,000. Plus 250,000.
Plus 250.
Plus 250,000. Yeah, so our summation is 2,560,000 million. So times again 1 million, but then there is no space to write that. You go ahead and now calculate.
Oh wow. Okay. Now
What's the formula of variance?
I think this is not in the variance.
That.
Yeah, we are going to.
First, write the formula of variance equals
variance is equal is equal to this one also. It is n minus now minus 1.
Yeah.
Then we have our answer. It is here. M. Remember that we have. We can let us count 1, 2. This is 5. No, sir? I think it is 5.
Yeah, 5.
5 minus 1. The name is this one. M minus the.
So we divide. Equals. Divide by
4.
640,000 M. So you write the actual full value here because that value with M is not correct. Write from here equals 640,000 another 1,000 times another 1,000. That's the actual value of variance. And what's the unit? In this case, we are talking of income. So let's say the units are shillings. It will be shillings squared.
Shillings.
Squared. Something like that. Okay, now go ahead and find the standard deviation.
Okay, standard deviation is equal.
Yeah? Okay, you're writing the whole formula? Okay.
Yeah.
Which is the same as square root of what?
Square root of
variance. Square root of
variance.
Because you have already calculated. So you substitute.
But the change is too big.
You squeeze it.
Okay.
640, sorry. 1,000. Like that. So what answer do you get? Okay. 640. 1, 2, 3. 1, 2, 3. 1, 2, 3. The answer is 800. Put the square root sign up. Our answer becomes 800,000. And the units are?
Shillings.
Yeah. So
Not squared.
we can clearly. So yeah, these are the values already calculated here. So there is a way for you to calculate those things using the computer, using Excel, without spending so much time. So now you say, like here, average, you just say equals to average, open brackets, you select this range. This is cell A2 up to these 2 dots means up to. Let me show. So here, if we were to say average equals to average, then we see the cell, our top value is on cell A2 up to cell A6. Or you can even just say A2, comma, A3, A4, like that. So A2 up to A6. If we want the standard deviation, we shall just say STDEV. This is the code for standard deviation, same range, A2 to A6. We'll do the same thing if we want the range, we want all. For range, for mode, median. So Excel can save time. Yeah, that's why we shall be learning. We shall cover some of the things. Even counting items equals to count. It gives you a number. Sum, maximum, minimum. Maximum is 2 million, minimum is 2. Range, then there are these two, kurtosis and skewness. Sample variance, standard deviation, all of it is given. Yeah, this is more clearly. Select the data, select data analysis, select the descriptive statistics, and click OK. Go to data analysis, and it does for you all of them. It can bring for you all of them at once. If you don't want to enter one by one, just go and select that.
Eh,
Excel, we shall cover that later on. I think Excel output. So I think that's it for today. All right.
Thank you, man. Thank you.
Let's go.